Hey, welcome back to your second and final lecture video of the first week of distance learning for Calculus 2. We're going to be, again, continuing to review things with limits. We're going to be talking about continuity and the intermediate value theorem. So one thing as a reminder is that you are going to have a quiz tomorrow on AP Classroom. There's going to be some math questions about limits, and there's also just going to be some questions that aren't AP questions, but that'll be just a chance for me to gauge how well you're understanding everything in Google Classroom, that you're able to find everything I'm posting, things like that. So expect to be able to sort of be going back and forth between those for a little bit, looking at different questions, and hopefully that will help me figure out exactly what skills I still need to help the group figure out how to use. On that note, everything for the week is due by Friday, so if you haven't already posted Tuesday's presentation, please do that. If you haven't already had your one-on-one meeting or at least scheduled it for later in the week, please make sure that you've done that. Make sure you filled out the quizzes, first day questions so I can gather that information. All of these things are super helpful. Nothing's going to be counted late until the end of the day on Friday. If you are stuck on any homework questions, please nominate them in the forms on the appropriate assignments, and I will get to those. If you nominated some questions, look back at those assignments, see if I've posted anything, see if I've maybe sent you an individual comment about a question that you asked about, if you were the only one who asked about that question, all those sorts of stuff. So I know there's a lot of information. Please, if you're confused about anything, let me know. I am trying my best to try to imagine what's confusing to students, but that doesn't necessarily mean that I know what it is. Quick deleting that number 3, we'll get to that in a separate slide. Let's talk first about continuity. So make sure you've got your notes and everything out in front of you, ready to go, however you're taking those. And let's start by making sure that we're all on the same page with our definition of continuous. A function is continuous at the point n, which is how you'd say that. So it's continuous at n when the limit at that point is equal to the function. Remember, the limit being equal means that the left-hand and right-hand limits are equal. Now, there's a couple of things that can cause discontinuities. We saw one yesterday where we have a denominator equaling 0. That's sometimes a removable discontinuity, like the example from the last lesson, and sometimes it will create an infinite discontinuity, which is an asymptote. So we might have something where it's removable, we just keep going. We might have an asymptote where it goes up forever towards infinity. We also might have a jump, which is what I illustrated in the left and right hand limits, where it's continuous on each side, each limit exists, but they're not the same. So often where things are discontinuous is two cases. One, it's where some sort of error is happening. So in this case, we have a denominator, and so it would be where that's equal to 0. And so you might ask yourself if it's a removable discontinuity or not, but it is going to be discontinuous at that place, which is all this question is asking. So it's discontinuous where x minus 2 equals 0, so it's discontinuous at x equals 2. And you could do further exploration to figure out which one of those it was. A very common type of AP question about continuity is something that's piecewise, meaning that we have one function here and a second that have two different conditions. So if g of x is equal to f of x does not equal 2, so we've got our function here. So if it's not equal to 2, which since this is the only discontinuity, that's fine, and c is equal to 2, find c such that g of x is continuous. So what we're supposing from this is that this is one of the removable discontinuities, like we see pictured over here. And the question is just what can we use to sort of plug that hole? What is our c value that's going to fix that discontinuity? So that discontinuity, that c value, there's a couple different ways to solve these problems. The way I'm going to solve this one is I'm going to say, well, c is then equal to the limit of f of x as x approaches 2. because that hole only exists, we can still find it using the limits, which to me says this is probably a removable discontinuity. I'm going to use factoring just like I did on the last video, and then I get x minus 2 times x plus 1 in the numerator here, factoring x squared minus x minus 2 over x minus 2. Our factors cancel out, and we're left with c is equal to the limit as x approaches 2 of x plus 1, which is just plugging in 2 plus 1, which is 3. So while f is not perfectly continuous, this piecewise function would be. Now, another thing that we worry about with continuity is the intermediate value theorem. So you might have seen this abbreviated as IVT. I'm just fine with that, as is AP. So if you want to abbreviate intermediate value theorem as IVT, go for it. The intermediate value theorem says that if f of x is continuous on an interval from a to b, and there's some n that's in between the f of a and f of b, the endpoints, then there's some c in a or b where f of c is equal to n. So this is all written out. I think it's easier if we look at a picture. So here we've got our function graphed on the coordinate plane. I'm going to go with a to b on the x-axis. And as we can see, we've satisfied this first thing. We are continuous on a to b. And then f of a would be the endpoint over here. And f of b would be here for the other endpoint. So, and then they're saying that there's some n in between f of a and f of b. So n would be somewhere in here, because we're in between f of a and f of b, which is on the y-axis. And the whole idea is that there's some value here that if I drew the line out, I'm going to hit the line, and then that's our c. So for everything, so for in between the y values, there's something in between the x values. It's sort of this contained system. Now, the intermediate value theorem is one of those things that seems pretty straightforward, but it's really, really helpful in some ways, such as for a very common type of intermediate value theorem problem, we have show that a root exists. Remember, root is just another word for 0. For y equals 4x cubed minus 6x squared plus 3x minus 2 between 1 and 2. So, knowing where a root is, we'd have to grab a calculator, do all these things. They didn't have graphing calculators back when they were coming up with all these calculus rules and theorems and discovering them. So, they could use this, though, because what it's really asking is, we want to show that y is equal to 0, right? Same thing as a root. Y is equal to 0 somewhere on the interval of 1 and 2. So if I'm looking at the intermediate value theorem here, that's going to be my a, that's going to be my b, and then this is my f of x. And since I want a 0, I'm looking for a y equals 0. I'm looking for this as my n value. So if I say, okay, well, what's f of a? Well, that's f of 1, which would be 4 minus 6 plus 3 minus 2, which is negative 1. And then f of b, which is f of 2 in this case, and that's 4 times 8 minus 6 times 4 plus 3 times 2 minus 2. So f of 2 is positive 18. If you don't believe me, I'm just going off of my notes from last year, so honestly, if you don't believe me, please check. You might be right. Check my work. But I think I'm probably right because I'm supporting this problem that we've been given, is that because we're looking for a 0, so since 0 is in between negative 1 and positive 18, there's a root, right? We don't know exactly where it is, but we know it's between 1 and 2, which is pretty close. So that's one type of intermediate value theorem when we're looking for 0, but this number could be anything based on the problem. Remember, you do have a quiz on AP Classroom on Friday. It's going to be some questions about limits, continuity, and the intermediate value theorem. It's also going to be some questions that I'll write just on AP Classroom and Google Classroom, how to use them. So if you haven't reviewed the course materials, I do recommend that. Some of it will be intuitive. You'll know this because you've been using it. Some of it will be very helpful to have read those. If you have any questions, please feel free to comment, get in touch, however is easiest for you, and I look forward to talking to you later.